We'll continue on to examples E and F. Again, sorry, I don't have the arrowheads here. Three factors, x plus 2, x plus 1, x minus 1. What's the degree? Obviously, if you were to expand it all out, you get degree of 3. Lead coefficient is positive. And because of that, notice that in general, the general trend of the cubic here, it's a cubic because it's degree 3, the general trend of the cubic is increasing. Obviously it does decrease momentarily before it continues increasing again, but in general the function is increasing. We have zeros at x equals negative 2, x equals negative 1, and x equals positive 1. So notice that this 0 is at x equals negative 2, and that corresponds to this factor of x plus 2. This 0 of x equals negative 1 corresponds to this factor of x plus 1. And this 0 of positive 1 corresponds with this factor of x minus 1. Turning points. Okay, there are two turning points in this case. And the ends go in opposite directions because it's degree 3. If we go along to example F now, 1, 2, 3, degree 3, lead coefficient is negative. Notice that the general trend of the graph is decreasing from left to right. Take a look at the zeros, and we have a 0 at x equals negative 1, which corresponds to the factor of x plus 1. We have a 0 of x equals 3, which corresponds to the factor of x minus 3, and a 0 of x equals 4, which corresponds to the factor of x minus 4. Okay, we've got two turning points. And the ends, because of the degree 3, ends go in opposite directions. And now we're into the cortex. 1, 2, 3, 4. Okay, that's degree 4. Lead coefficient is negative, which indicates, in this case, it's opening down. Because of the degree, the ends are going in the same direction. And we take a look at the zeros. So we have zeros at x equals 1, x equals 2, x equals 3, and x equals 4, corresponding with the factors x minus 1, x minus 2, x minus 3, and x minus 4. And we see also changes from increasing to decreasing to increasing to decreasing. There are three turning points. Moving along to part H, we have 1, 2, 3, 4. Okay, again, degree 4. Positive lead coefficient. That means that it's opening up. And the zeros, we've got zeros of x equals negative 2, x equals negative 1, x equals 1, and x equals 3. corresponding with the factors of x plus 2, x plus 1, x minus 1, and x minus 3. And again, 1, 2, 3. 1, 2, 3 turning points. Okay, so a couple things to notice when we look through this. First of all, notice let's take a look at the lead coefficient, and for even degrees, degree 4 or degree 2. So degree 2, when lead coefficient is positive, it opens up. Lead coefficient is negative, it opens down. Degree 4, lead coefficient is negative, opens down. Lead coefficient is positive, opens up. Okay, so I always kind of think that perhaps a positive person might be smiling, might be happier, so they would be opening up like this, the smile, and a negative person might be a little bit more down, and so they may be frowning. And then let's take a look at the cubics. Lead coefficient being positive, these two are positive. The general trend of a cubic, and perhaps we could even extend that to any odd function. If it's positive, it will be general trend is increasing from left to right, and for a negative, the general trend, so a negative lead coefficient for a cubic or an odd powered polynomial, the general trend is decreasing from left to right. Okay, and then let's take a quick look at the zeros. Notice that, we'll take a look at the zeros first. We see that we have a degree 2, and we have 2 zeros here. Degree 2, we have 2 zeros. Degree 3, we've got 1, 2, 3 zeros. 1, 2, 3 zeros. But also, let's take a look at this degree 3. We've only got 1 zero. And same with this one. Okay, and as you know, if we were to look back at the degree 2 for a second, you know that parent functions of parabolas also just have 1, 0, where the vertex is right at the origin. Okay, so just some things to think about. And then for a quartic, degree 4, 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. But also, a quartic may not look like that. A quartic, from later on in the lesson, a quartic may look like this. So this is the parent function, this isn't one, this is the parent function of a quartic with more of a flat bottom here compared to the parabola, which is more rounded. But notice that both of these only have 1 zero, even though there's degree 2 and degree 4 respectively there. And now if we take a look at one other little thing to pay attention to are the turning points. A parabola has 1 turning point, degree 2, 1 turning point. Parabola here, degree 2, 1 turning point. A cubic, degree 3, 1, 2 turning points. Degree 3, 2 turning points. However, these ones actually don't even have a turning point, these cubics. Okay, something else to kind of pay attention to. And then here for the quartics, degree 4, 1, 2, 3 turning points. And this quartic also, degree 4 obviously, 1, 2, 3 turning points. Okay, so just some things to think about here. What I'd like you to do now is pause the video and sketch the following curves. You've got 4 curves to do, A, B, C, and D. So please sketch those curves and pause the video to do that, and then come back for the big reveal that I have waiting for you here.